Hello there, Mr. Sutton bringing you these AB Calculus 6.5 classwork solutions on exponential growth and decay. On this problem, we have radioactive isotope decaying at a rate proportional to the amount present. So immediately we're going to go to our decay formula, y equals CE to the negative KT. And then our decay rate is 14.65, so that's a K value of 0.1465. And then current mass is 130.6, so that's our C value. We want to know what the mass was 4.9 thousand years ago. Now, it says that the decay rate is this percentage per 1,000 years. So when we plug in 4.9 thousand, we're actually going to plug in the number 4.9 because that's what everything else is expressed as. And since this is 4.9 thousand years ago, we have a negative 4.9 going in there. So when the dust settles, here's what all this looks like. We have 130.6 e to the negative, that was our K value, 0.1465 t. And now for, again, our t value, that's going to be negative 4.9 getting plugged in. And now we go to the calculator. So there's everything we need to enter in the calculator. Pressing enter. This comes out to 267.733 if we round off to 3 decimals. And that's going to be in milligrams because we're talking about mass. For this problem, we have a savings account with a balance that's compounded continuously. So right off the bat, that's exponential growth. We've got y equals CE to the KT, or the PERT formula from years ago if you wanted to use the old one, but this is kind of the new calculus version. And we have a balance that they're giving us 5.9 years ago and a current balance of $1,252. Based off that, they want the balance 5.6 years from now. So we've got, eventually we want to solve for the balance in the future. So we're looking for this y value. That means we need to know C, K, and T. We know C, it's this 1252. T, we know is going to be 5.6, but they did not give us the K value. They didn't give us the growth rate. So we're going to have to find that. To find that, we're going to use this other information they gave us. They said that 5.9 years ago, so at a t value of negative 5.9, the balance was $1,036.60. So we can plug those two numbers in along with this current balance, and that'll help us solve for the K value. So I can say my initial target value here, so $1,036.60 equals my current value of 1252 times e to the k times negative 5.9. And now I can solve this for k. So to do that, I'll start by dividing by 1252 to isolate the exponential term. And then I have to take the ln of both sides to get rid of this e. So that just leaves me with negative 5.9k on the right side, and all of this stuff inside one big ln on the left. Now we'll divide both sides by negative 5.9 to figure out k. So there we go, dividing, and that comes out to some crazy decimal here. Now I'm not going to round this off. I am going to store this. So I'll press the stow button here and store this as alpha A or alpha something. Just pick a letter. So now that I've done that, I can actually use that value exactly and not have to lose accuracy by rounding. All right, so I'm storing this as A, and again, A was this crazy decimal right here. I'll just write out the first 4 digits. And now I've found the K value I was missing. I can go back to the original formula and plug in what I need to get my Y value. So I have, again, an initial value of 1252. I have a K value now of A. It's actually this decimal here. And I want the balance 5.6 years from now. So now my T value is this 5.6. But we couldn't use that until we had the K value to go with it. So back to the calculator to plug all of this in now. So I've got 1252 e to the a times 5.6. Enter. That's $1,497.71. On this problem, if P of t is the size of a population at time t, which of the following diffie-qs describes linear growth in the size of the population? So if we have linear growth in the population, that means it is growing at a constant rate. Linear growth means we have a constant slope. So which of these has a constant slope? Well, all of these have variables in the second half of the equation, except for this first one, choice A. This is just growing at a rate of 200 people or whatever per time unit. So choice A is the way to go on this one. On this problem, we have a population Y growing according to this differential equation. K is a constant and T measured in years. If the population doubles every 10 years, we want the value of K right here. All right. So this is really just exponential growth whenever you see something growing at a rate proportional to the output variable when you have a y here. So I'm going to rewrite this as just y equals CE to the t. And I mean, you could do the differential equation dance and eventually get here, but it's faster if you just know that this is what you need. So population doubles every 10 years. We want the value of k, and it's still the same k here. This k and this k are actually the exact same k. So that means if I'm ultimately solving for k, I need to have values for y, c, and t. So we're told that the population doubles every 10 years. I don't know what the initial population was, but I know in 10 years it's going to be 10 times, it's going to be 2 times that. It doubles. So we can write 2c equals c times e to the k times 10, because they said every 10 years this happens. So every 10 years, population doubles. We actually have everything we need now to solve for k. We don't know what c is, but they cancel out anyway when we divide both sides by that. So we just have 2 equals our exponential term. Now to get rid of e, I have to take the ln of both sides. So I have ln of 2 equals just 10k. And dividing both sides by 10, let's see what that ends up giving us on the calculator. So plugging that in, we get about 0.069, which is going to give us answer choice A. For this problem, if dy over dt equals k times y and k is a non-zero constant, then y could be, now this is definitely an exponential kind of setup here, but we have a few exponential looking choices here. So just to be on the safe side, we're going to go ahead and figure out what happens if we do our differential equation dance. Since I have an output variable in the differential equation, I need to separate my variables. So I'll divide both sides by y. So that's 1 over y dy on the left. And I'm going to multiply dt to the other side to be with the k value. There's no t values, but we don't care because the dt's got to go. All right, taking the antiderivative of both sides, we're going to have ln absolute value of y on the left side. On the right side, this is just a constant k here. So this is just k times t, all that plus c. All right, they did not give us any kind of differential or any kind of initial condition to our differential equation, but we still have to figure out what this looks like when we isolate y. So to do that, we first need to figure out whether this absolute value is just plain old ln of y or ln of negative y. Looking at our answer choices, we notice that all of these answer choice expressions here are positive. That means that we're going to pick positive y instead of negative y to be inside our ln. So I'll just rewrite this as ln of positive y equals kt plus c. All right, now that we've passed that minor hurdle, we're going to raise e to both sides to get rid of the ln. So I have y equals e to kt plus c, all inside the exponent. And of course, that doesn't match really the pattern for any of these answer choices. It definitely looks like it's going to be A, B, or C, but let's go a little bit further. So now if I wanted to, I could split this up into e to the kt times e to the c. And we don't know what c is, but e to the c very well could be this 2 right here. We don't know, but it could be. And that's what they said. Then y could be. So we have to match this with the closest pattern. Now, we have 2e to the kt, which would definitely match this pattern. The only other choice that really sticks out here is this 2e to the kty, but there's no y here because we isolated y. So A isn't very good. And also choice C, if you were worried about, well, there could be a plus 3 there, well, there can't. The constant that could be anything is kind of looped up here, and it ends up as a coefficient on your E. So this is going to have to be choice B. For this problem, during a certain epidemic, the number of people infected at any time increases at a rate proportional to the number of people infected at the time. So if we're increasing at a rate proportional to the output value, this is definitely an example of exponential growth. So I'm going to start off by writing y equals CEK to the t, because I know it's going that direction anyway. Now, they eventually wanted to figure out how many people are infected 12 days after the epidemic. So eventually, we're going to have to plug in 12 for t and figure out what y is. That means we need to know the current population rather, and the k value, the infection rate. Well, we already know the current value. They said if 1,000 people are infected when the epidemic is first discovered, so 1,000 is going to be our c value here. But they didn't tell us the k value. Instead, they told us that 1,200 people are infected 7 days later. So we're actually going to have to use this in order to work backwards and find the k value. Once we've done that, we can plug in the k value with 1,000 for c and 12 for t, and that'll give us the number of people infected, one of these answer choices. All right, so I'm going to start off by letting my y value here equal 1,200 with a t value of 7. So I'm going to write 1,200 equals 1,000, because that's my current value, times e to the k times 7. And at this rate, I'm going to just solve for k. So divide both sides by 1,000, and then let's take the ln of both sides to get this out of the exponent. So I have ln of 1.2 equals just 7k, because ln of e is just 1. Now I'll divide by 7 to figure out my k value. So I end up with a k value of about 0.0260, and I'm actually going to go back and use that value directly. So let me just store that as a on my calculator so that I can go back and use it whenever I want. All right, so I'll just write this out just so we have something that k is approximately equal to. But again, we're going to use the exact value. Now that we've got k, let's go and plug that in along with our other values to get that ultimate y value we were looking for. So I'm going to write y equals, we still have 1,000 people initially infected, times e to the this stuff times 12 now. And let's see what that looks like on the calculator. So let me just move my calculator. There we go. We've got 1,000 times e to the, and again, I'm going to use the a value that I just stored here. So that is this value here, just more decimals and more accurate, times 12. And all of that comes out to 1,300, and if we round off to the nearest person, 67 people. So that comes out to choice C. On this problem, at time greater than or equal to 0, a cube has volume v of t and edges of length x of t. The volume of the cube decreases at a rate proportional to the surface area. We want to know which of the following diffie-q's describes the rate at which the volume of the cube decreases. So we're looking for dv over dt on all of these, and they gave us all those in the answer choices. But they're not this isn't your standard kind of exponential growth sort of differential equation where you have a v in the output, because here they said the volume of the cube decreases at a rate proportional to the surface area, not to the volume. So we have to think a little bit outside, well, the cube on this one. So we have a surface area for a cube if we have an edge length of x of, well, there's 6 faces, right? And they're all x squareds for area. So that's 6x squared. And note that they did not give you that information in the problem. You had to kind of figure that out and remember it. Now, writing out our differential equation, if we said the volume of the cube decreases at a rate proportional to the surface area, that means dv over dt equals negative k, because we're decreasing, times the surface area. Well, what is the surface area? It's this 6x squared that we just talked about. So we can really write this as negative 6k x squared. And at this point, it'd be great if we knew what that k value was, but they didn't really give us a whole lot of information in this problem. So at this point, all we can do is try to pick an answer choice that matches this pattern. So if I look here, the only variable I actually have here is x. K is a constant. So looking at my answer choices, C, D, and E have to be eliminated because they all have variables that are not x. I mean, C has an x, but it also has a t, so that's no good. So it's down to A or B. Now looking back here, this is x squared. And A has an x squared, whereas B does not. So I'm going to choose choice A then, because that's the best match.